Hi everyone, and thanks for watching CBS 19 Plus. I'm Chief Meteorologist Brett Anthony, and today we have another weather experiment for you. You know, a lot of times on the weather we talk about when it's extremely hot, about wearing lightweight, light-colored clothing, and it also should be loose-fitting. A white shirt on a hot day like today is perfect because the sun, or white will reflect more of the sun's solar energy than, say, a darker shirt. So what we're going to do is demonstrate that by using crayons. We're also going to create some artwork. So what we've done is we've got a piece of cardboard. Once again, we're always looking for products that we can recycle. We've taken some white, this is paper from our printer, so we didn't necessarily recycle it, but if say you had something on the one side, you wanted to flip it over, you could use that side. We got some tacky glue spray. You could use Elmer's, but I think some sort of tacky or glue spray, something that you could spray on there. And then we let that set up. So we didn't quite get, let's say, where it wasn't tacky. It's still a little tacky, right? So what we've done is we sprayed that on there. We let that set up a little bit. Then we sprayed the back of these crayons, and we picked different colors. We have darker colors. So what we're going to demonstrate is how the heat from the sun shines down on these darker crayons, and these darker colors absorb that heat, and then they begin to melt. So at 105 degrees, when this temperature gets to about 105 degrees, the crayons should begin melting. If we could get the temperature up to 120 to 147 degrees, the crayon would completely melt on down the paper. I think we'll get somewhere at about 110 to 115, because what we're doing is we're shooting it against a wall, and when we have that reflectivity coming off the pavement, then that is going to only add to the heat that we see here. Remember that when we take the air temperature, that's taken in a louvered box, so that's the shade. So the sensor's inside a louvered box. So the temperature is taken in the shade, and it's 3 feet off the ground. At the surface, it's gonna be a lot hotter. So we are going to place these crayons closer to the surface so that we are maximizing the amount of solar radiation that the earth is absorbing, or at least this concrete is absorbing right here. Of course, if we did it where this was blacktop or asphalt, this would reflect up a ton more heat. But it's kind of gray, so it's not going to reflect as much heat, but I think it's going to do the trick. So again, we placed the crayons onto that tacky, we sprayed that tacky stuff on the back of the crayons, then we placed that onto the glue that was already on this cardboard with this printer paper on here. So we're going to set it next to the wall, and then we're going to come back in an hour and see what kind of artwork we have. So here's where we're going to set this down. Okay, so we set our cardboard with the crayons glued to it down here on this pavement, and I got to tell you, the pavement is pretty hot. I mean, I can keep my hand here, so it's not to where it's untouchable. But I know that this is hotter than the air temperature right now. So there's a lot of heat being reflected back up here. If you wanted to speed up the process, you could put some aluminum foil down here. You can even put a little bit of aluminum foil just underneath the crayons and let it drip over the aluminum foil and onto the white paper. That would maximize the heat. So again, the sun's hitting here about 105 degrees. This probably feels like it's at least 105, maybe 110 degrees right now on the pavement, maybe 115. I mean, I can't leave my hand there. It's pretty hot. So that heat's being reflected up, and then I'm gonna guess in about 15 minutes we'll start to see some drips, but we're gonna check on this in 1 hour and see what kind of beautiful artwork we have, okay? All right, so not all experiments work out the way you want them to, but I think we get a notable science lesson out of what we did. Remember, we took crayons, we glued them to this board, and then we wanted to get the temperature up to 105 degrees to melt the crayons, to at least start melting them. If we could have gotten the air temperature up to 120 to 147 degrees, or at least the temperature that was reflecting off the concrete up onto the crayons, we would have had the crayons melt excessively. For a while, I think we had the temperature up to about 105 degrees. The sun was very high in the sky, but we had some clouds sort of come over the sun and block that solar radiation. So we didn't get maximum solar radiation throughout our experiment. Therefore, I think it slowed it down just a little bit. But a couple of things to note here. You will note that the darker colors, we did get the wax to melt and run all the way to the bottom here. In the purples, the oranges, the blues, the white is sliding. I'll talk about that in just a second. But if we look at the blues over here and the purple, also you can see how it melted at the top. So those colors ran all the way down. But the science lesson that we're going to get here, and this is why we talk about not wearing dark colored clothing on very hot days like today. Well, it's because those darker colors are absorbing more of the sun's solar radiation, or more of the sun's energy. And so as those colors absorb the sun's radiation and the sun's energy, those colors got warmer. They reached that 105 degree critical temperature to start melting. The yellow and the white did not. It reflected more of the sun's energy off of that surface. And so we just got a little bit of melting on the yellow, but the white, we really didn't get any melting at all. In fact, if I touch the white, I don't see much of that running off on my fingers. Those darker colors that we were talking about, can you see that? On the purples, the oranges, and the blues, yeah, a lot of that melted, and a lot of that is creating what we'll get here with our artwork. In fact, it really feels hot across the top in some of those darker colors. So the colors didn't run, but it does kind of create this nice little pastel-y color that I can run down here and maybe make just a little bit of nice artwork on the bottom. I feel like Bob Ross doing this. That's very hot when we do that. In fact, wax can get really hot. And on this side, on the blues and the black color, we'll run that down here and we'll smudge that out. Boy, that's really hot. And then on the red and the orange down here, we didn't get as much. We just get a little bit. That was probably getting just a little bit of solar radiation, but not as much. So we'll just blend that all. Man, that is hot. Woo! Some of those are really, really toasty. We'll just blend that all together and make our little art that way with our finger. So anyway, that was our experiment. Well, our goal was to have these colors nicely drip and run down to the bottom and create this nice little streaky artwork here using the sun's solar radiation to melt the crayons, and then have the crayon colors sort of melt out of here. The crayons I bought might have been made, let's say, more of wax and less of what would be important in the crayon ingredient to get the color to run. But nevertheless, that was our experiment for today. Again, we took some crayons, we glued them to this board, we took some white paper, we taped that to the cardboard, we set it up in the sun. It might have worked better had we done it at 10 a.m. till about noon when we had really strong solar radiation. We waited till mid to late afternoon, so we got a little less of the sun's energy coming in here. But that's what we get, and that's our science lesson for today on CBS 19 Plus. If you have some time and you want to melt some crayons, create some pretty art, give that a try. Thanks for watching CBS 19 Plus.